Good evening, everyone. Myself, Nishi, and today I'm here to present something about Booth's algorithm. So, Booth's algorithm is a very important topic of computer organization subject. So, over here, I'm here to discuss something about Booth's algorithm and hope you enjoy this video. Okay. So first of all, we'll move to the content portion. So what we are going to see today in this video. So first of all, we are going to see about introduction, what exactly Booth algorithm is and why we use it. We are going to see the history and we are going to see the flow chart about how the Booth algorithm works. And we are going to see examples of signed integers, signed multiplications and unsigned multiplications. Okay. So basically, what are signed numbers and unsigned numbers? So basically, signed numbers are the numbers which just indicate that the number is positive or negative, okay, by indicating the value 0 and 1, okay. And in unsigned, you don't need to mention that. So let's move on to the objectives. So what are the objectives? First objective is to provide knowledge on signed and unsigned multiplication. Okay, so what is the difference between signed and unsigned multiplication? Then we are going to solve some problems on the Booth algorithm to make it more clearer for you, and to just know how the procedure for binary multiplication using Booth algorithm exactly works. So let's move on. What is Booth's algorithm? So Booth's multiplication algorithm is an algorithm in which we just multiply two signed numbers or two unsigned numbers, and the numbers are in 2's complement form. Okay, so this approach uses fewer addition and subtraction than more straightforward algorithms. Okay, so now let's move on to the history. So from where did this Booth algorithm originated? Okay, where did this Booth algorithm came from basically? Okay, so the algorithm was invented by Andrew Donald Booth in 1950 while doing research on crystallography at Birkbeck College in Bloomsbury, London. Okay, so this is the place. Now, points to remember, these are for the unsigned integers. Okay, so firstly, we are having two registers, okay, Q and M, and these two registers load the value of multiplicand and multiplier. Okay, for example, if you want to multiply 4 with 5, so 4 is the multiplicand and 5 is your multiplier. So these two values will be stored in Q and M. Okay, next comes, we need the third register, that is accumulator register, which we are indicating by a value. Okay, so first of all, we initialize it with the value 0. Okay, we also need one more register to just store the carry value. Okay, if you are getting a carry in addition, then you need one bit register, that is q minus 1, to store that carry bit. Okay, so multiplicand M is added to register Q and result is stored in register A. Okay, A is your accumulator register, and all the bits of A, Q, Q minus 1 are shifted to right one bit. So basically we are performing arithmetic right shift over here. Okay, so depending upon the last bit of Q, single bit of Q minus 1 following arithmetic operations are performed. So basically what we need to do, we need to see the last bit of Q minus 1 and the value of q minus 1 bit. Okay, so if the last bit of q is 0 and if the one bit of qn minus 1 is 0, so we are having 0 0 value, so there won't be any arithmetic operation. You just need to shift the right one digit right to that. Okay, if the value is 0 1, then you need to add multiplicand to the left half of the product. If the value is 1 0, then you need to subtract multiplicand from left half of the product. And if the value is 1 1, again you don't need to perform any arithmetic operation, you just need to shift right. Okay, so now we'll see signed numbers. Okay, how to deal with signed numbers. So over here, first of all, we'll learn how to convert to 2's complement. Okay, so what you need to do, you need to take a number. Okay, for that number you need to find the binary digit. Okay, you need to find the binary value of that number, and after converting into binary, you have to convert all the ones into zeros and zeros into ones. That will be your ones complement. Okay, and after adding 1 to 1's complement, you will get your 2's complement value. So over here we take the example of minus 5. Okay, so first of all, convert 5 to binary digit, then just do 1's complement. For that we are converting 0 to 1 and 1 to 0, and then we are adding 1, so we'll get our 2's complement value. Okay. So how to perform binary addition? Now in binary addition, if 1 plus 0 is given, then the answer is 1. If 1 plus 1 is given, answer is 0, and you will get a carry 1. Okay. And if it is 0 plus 1, you will get answer 1. If 0 plus 0, you will get answer 0. So over here one example is given. In that example you can see from the rightmost side, 1 plus 0 you will get 1, 1 plus 1 you will get 0 with 1 carry bit. So 1 is going upside in the carry. Again 1 plus 0, but we are having 1 in carry, so it will be 0, and again 1 in carry, and so on goes. So over here we have dropped the leftmost carry, that is the 1. We have just dropped that value. Okay. Now we'll go to binary subtraction. Now how subtraction occurs? So if it is 1 minus 0, you will get 1. If it is 1 minus 1, you will get 0. If it is 0 minus 1, you will get 1, but with a carry 1, or you can say with a borrow 1. Okay, 0 minus 0, you will get 0. Again, we have taken the same example to just explain binary subtraction. So 0 minus 0, 0. 0 minus 1, you will get 1, and you will have 1 carry. Okay. So that's how we perform the binary subtraction. Now moving to the flow chart. Now here there is a flow chart of Booth algorithm. So in both algorithm, first of all, you are having accumulator register which have the initial value of 0. You are having Qn minus 1 which is again initiated with 0. Then you are having a multiplicand m, you are having a multiplier q, and you are having a counter value n. Now what you are going to do with the counter value, you are going to decrement the counter value with each and every step so that the counter tends to 0. Okay, so over here qn and qn minus 1, if the last bit of qn and qn minus 1 bit is resulting into 1 1 or 0 0, then you are going to perform the arithmetic shift right. Okay, and then you are going to decrement the counter as I told earlier. Okay, but if the value is 1 0, then you are going to subtract a minus m, and then you are going to perform arithmetic right shift, and then you are going to just decrement the counter value. If the value is 0 1, then you are going to add it. Okay, so a plus m, then you are going to perform the arithmetic right shift, and then you are going to decrement the counter by 1. Now if the counter value is 0, then you are going to end the procedure, but if the counter value is not 0, then you need to repeat the procedure again. Okay, now let's take an example to just understand what I just explained you in the flowchart. So over here we are having 7 multiplied by 3. Okay, so first of all our first step would be to convert 7 and 3 into a binary digits. Okay, now as you know, accumulator is given the value 0, so accumulator is given the value of 0. Now we take the value of q, that is 0 0 1 1, that is 3. Okay, q minus 1, again you are having 0 initiated value. Okay, and then m value is 0 triple 1, that is your 7 value. Okay, now just see, the last bit of q is 1 and the one bit of q minus 1 is 0. So you are having 1 0. So in the first cycle you are going to first perform the subtraction as I have already shown you in the rules before. Okay, so we are going to perform subtraction, and then after that we are going to perform arithmetic right shift. So we have just performed the arithmetic right shift over here. Now in arithmetic right shift, what you need to do, the first digit of your number shows your signed bit. Okay, so over here 1 shows your sign bit, so keep 1 as it is, and then you need to shift each and every digit from 1001, each and every digit towards your right portion. Okay, so see 1 1, and then shifted 0, then shifted again 0, and then shifted 1 to the q value, and again we just shifted accordingly. Okay, so this is your arithmetic right shift. Okay, now we'll again check the value of last bit of q and the one bit of q minus 1, it is 1 1, so we just need to perform arithmetic right shift. We don't need to perform any arithmetic operation, we just need to perform the right shift. So again we did the right shift keeping 1 as it is as the signed bit value. Okay, then later on again we are comparing the value, it is 0 1, last bit of q is 0 and q minus 1 1. Okay, so 0 1, so we are performing addition, and after performing addition we are doing the right shift as per the rules, and again we are seeing the value. So over here we are getting the value 0 0. So for 0, 0, no arithmetic operation, you just need to perform the right operation. So again, you are just shifting it and you are getting the value. So this was the first example. Now move on to one example which have a negative value. Okay, so what you need to do for negative value, first of all, for minus 3, first of all you need to convert 3 into your binary value. Then after converting 3 into binary value, you need to do 1's complement. Okay, and in 1's complement you need to add, so add 1, so you will get the 2's complement. Okay, now how to do 1's complement? Converting all the 1 to zeros and zeros to 1's, that is your 1's complement, and plus 1 you will get your 2's complement. So following this procedure, we are getting a0 initialized with 0, and then we are having q minus 1, m, and we have kept all the values, and we need to just perform the same procedure as I explained you earlier. Okay, so over here we are having 1 0, so we are going to perform the subtraction. Okay, so we have performed the subtraction, then we just went on for the right shift. Okay, keeping one value as it is because it is a sign bit, so keep first value as it is and then do the right shift accordingly. Now we'll again check the value, so it is 0 1. So for 0 1 you are going to perform the addition, so we are going to add the digits, and again we are going to perform the right shift, and with right shift you have to keep the first digit as it is. Okay, because it is the multiplication of sign numbers. Okay, after that we are getting the value 1 0, so we are going to perform the subtraction. For subtraction, again we are going to perform subtraction, again we are going to do the right shift, again we are going to check the values, and we are having 1 1, so again we are going to perform the right shift without any arithmetic operation. So this is how we'll do the multiplication of 7 into minus 3. Now you can convert this last answer into the decimal digit, and you can verify that your answer is correct or not. Okay, so yeah, that's it from my side, and here are some of the references which I have used. So these are some references, even you can watch it if you want. So thank you so much for investing your time and just listening to my explanation. Thank you so much. Thank you.